Well, hello and welcome to our topic tonight. We'll go ahead and title this Intro to Functions. So let's take the time to carefully write out the definition of a function. So a function is a rule that converts inputs to outputs in such a way that each input, whoops, sorry for my sloppy writing there, has one and only one output. So if you need to pause it and copy it, go ahead. But a function is a rule that converts inputs to outputs in such a way that each input has one and only one output. Now a quick reminder, what's an input or an output? Well, they're just the way that sounds. Input is what you put into something. So our input represents the variable x, and our output is what you get out. What is it equal to? And it's always equal to our y value. So when we say input, we're referring to x, and output, we're referring to y. A function can be expressed in four ways. So again, I do want you to pause it, and the best sketch you can do on each of these is perfect. So one of the ways would be an equation, and here's an example of equation, y equals mx plus b, the equation of a line. To a graph. When you're sketching this, it doesn't need to be perfect. Go ahead and just sketch an x and y axes and carefully draw that in. A table of values, and a mapping. Alright, our first exercise. One of the following graphs shows a relationship where y is a function of x and one does not. Part A says draw the vertical line whose equation is x equals 3 on both graphs. So, I'm going to go to the x-axis and I'm going to count over 3 spaces, 1, 2, 3, and x equals 3 is a vertical line, so it starts with x equals, and we'll draw it, and of course we'll label everything as we graph. So x equals 3, and it says do that on both graphs, so I'm going to go ahead and do it on the second one as well. Alright, part B says give all output values for each graph at an input of 3. So let's go back and look at graph A. You'll notice when x is 3, the output could be up here on this function, so the output could be 1, 2, 3, 4. So it could be 4. But you'll notice that it has a second output. It could also be 1, 2, 3, negative 4. So in relationship A, when x is 3, and the vertical line made it perfect, when I drew that in, I could easily see it has an output of positive 3 and an output of positive 4 and an output of negative 4. Now we'll do the same on relationship B. When I draw that line, x equals 3, it only hits the graph once, so it has one output, and if I count down, it looks like that's at negative 2. So now it says explain which of these relations is a function and why. So if you go back to the definition we just wrote down, a function is a rule that converts inputs to outputs in such a way that each input corresponds to one and only one output. So based off that, you are only allowed to have one output. Relationship B, and we'll go ahead and label it, is a function, and relationship A is not a function. Okay, again, when I drew that line in, this had 2 outputs, and this only had 1 output. And our definition said we could only have 1 output. Now, back in algebra, you probably talked about something called the vertical line test, and let's go ahead and get that in there, in your notes. So this is a quick and easy way to tell if you're given a graph if you have a function. The vertical line test says your vertical line can only hit the function once. And again, this vertical line hits twice, so it's not a function. This vertical line hits once, so it is a function. Now, second part here says looking at relationship B, we'll just state some other fun facts that you should know about these graphs. So the first question does say state the y-intercept. So the y-intercept is very simple. I'm just going to go to the y-axis, and I'm going to look and see where the graph crosses the y-axis. And hopefully you can agree it crosses right there, and I would say the y-intercept is 1. And I'm going to put y equals 1 because it's asking for the y-intercept. The second question, how many zeros are there? Well, remember, a zero is just where the graph or the function hits 0, has a height of 0. So I'm going to go ahead and circle my zeros. I would say there's a 0 here, here, and here. A total of 3 zeros. Now notice it didn't say what are they, it just said how many. The next question says, the largest zero falls between what two consecutive numbers? Well, the largest zero would be the one over here. So the question is, between what two numbers does that 0 fall? Well, it's to the right of 3, and it's to the left of 4. Would you agree? It hit that 0 is between 3 and 4, so that would be my answer. I'm going to say between x equals 3 and x equals 4. So if you had to guess at what that 0 could be, I can make one more educated guess. It looks like it's a little further than 3.5, so maybe I'd say like 3.6, 3.7. And then my last question there, the smaller 0 falls between what two consecutive numbers? So again, here's my smaller of the zeros. There was 3, the smaller one's down here. We'll just have to count it out. 1, 2, 3, 4, and 5. So I would say between x equals -4 and x equals -5. Okay, so again, I could make an educated guess. It looks like it's a lot closer to -4 than it is to -5. So maybe the 0 is like -4.1. Okay, in this section, our goal is to determine if we have a function or if this picture is not a function. And it's very simple. We're going to use the tool that we just talked about, that vertical line test. Okay, and the vertical line test is very simple. We just did in the last example. When you draw that vertical line in, it can only hit the function once and only once. That was our definition of a function. So I'm going to take a vertical line, and hopefully I'll be able to move it here. Oh, and it won't let me pick it up. Let me try another one. Okay, I can pick this one up okay. And I'm going to take this vertical line and just swipe it across. So you can see right here, I'm hitting that function, kind of the upside down frowning face. I hit it once. And as I sweep it across, it hits once, it hits once, it hits once. It's only hitting this function once as I sweep it across. So I would say this is a function. Okay, it passes the vertical line test. Each input has one and only one output. Now let me take my vertical line and sweep it across the second graph. Look what happens right here. How many times does this vertical line hit the function? I hope you're screaming too out loud. It's definitely hitting twice. The second it hits twice, it's automatically not a function. Now you'll notice even if I come down here, is it hitting twice? Absolutely. It's hitting here and here. So I just want to be very clear, this is not a function. Each input does not have one output. At x equals 2, it has an output here and an output here. This is not a function. Now we can do the same thing with a mapping. We saw earlier mappings can and cannot be functions. So you just have to say to yourself, does each input have one output? Well, 1 goes to A, in one input, one output. 2 goes to D, one input has one output. 3 goes to B, and 3 goes to C. Well, this input has 2 outputs, so that's not a function. Now maybe that was difficult for you to see that way. Let me plot it out. I've got 1, 2, and 3 as my x's, and my y's are A, B, C, and D. Okay, if you ever get stuck, just plotting these points is simple. So 1 goes to A, 2 goes to D, 3 goes to B, and 3 goes to C. Now watch that vertical line. If I draw the vertical line there, it's a function, it hits once. If I draw it here, it's a function, it hits once. But watch what happens here. That hits twice. Therefore, this is not a function. Each input did not have one output. And you can obviously do the same thing in a table. Does each input have one output? 1 went to 2, 2 to 4, 3 to 6, 4 to 8, 5 to 10, 6 to 12. And again, if you can't see whether it's a function or not, plot the points. 1 goes to 2, 2 goes to 4, 3 goes to 6. Is 3 going to any of the same two numbers? No. 4, 5, or 6? No. So if you were to continue plotting these, I just want to be clear, this one is a function. Alright, now's the time to work on our function notation. Now, you're really not going to see y equals anymore for the most part. You're going to see function notation, which is f of x. So let's get that down in English on paper so we know how to read it. Right here in your box, and we'll box this in as well, this is read f of x. When we see those parentheses, we say the word of. So f of x. Notice y is the output, and whatever I put inside the x there is my input. So exercise 1, evaluate each of the following given the definitions and input values. So here's the function, f of x equals 5x minus 2. Now remember, this is like saying y equals. You just got to get that in your head. F of x is our function notation for y equals. So I'm basically saying y equals 5x minus 2. And I want to find f of 3. Well, notice, look at here, my input is what's inside those parentheses. So if I want to find f of 3, and I'll work it out down here, I'm going to say f of 3 equals, and I'm going to replace all my x's with 3. Notice I'm using parentheses when I substitute. So 5 parentheses 3 minus 2. 5 times 3 is 15 minus 2. I should get 13. And we'll do f of negative 2. F of negative 2, so say it out loud when you write it, is equal to 5 parentheses negative 2 minus 2. 5 times negative 2 is negative 10 minus 2. That's going to get me negative 12. All right, let's try another one. Now, it doesn't have to be F. It could be G, H, M, P. It doesn't matter. Pick your favorite letter, and if you put of x, you're in function notation. So you'll notice this time they're going to use g of x. No big deal. It's the same thing. This is like saying, again, y equals x squared plus 4. Okay, so if I want to find g of 3, g of 3 is equal to, substitute 3 into all the x's. That is your input. Notice where I put my parentheses and where I put my exponent. When I substitute in, I put the parentheses around it, and my squared goes outside. So order of operations, parenthesis exponent, so that's going to get me 9 plus 4 is 13. If I want g of 0, okay, so parentheses, substitute in, squared, plus 4. 0 squared, of course, is 0, plus 4 should get me 4. All right, you've got question C. Pause it, try it on your own, and then compare to what I have. So go ahead and pause it. All right, so notice I said h of 3 equals 2, raise it with parentheses to the third, which really means 2 times 2 times 2. I got an 8. And then h of negative 2, 3 to the negative 2. Well, what I do in my head, since I don't have a calculator, I'm saying ignore the negative. 3 squared is 9. And now a negative exponent moves your answer to the denominator, so 1 over 9. And perhaps you used your calculator and got a decimal, but it converts to 1/9. All right, let's try evaluating one more function. F of x equals 2x squared minus 1 over 2x minus 6. So we want to find f of 4 using the store feature on our calculator. So recall we've talked about storing on our calculator before. I'll write it out one last time. You start with the number you want to store, and you say 4 store into x. So I have my calculator here off to the side, so I'm going to hit 4 first, then the store button is STO, and then x is right here. 4 store into x and hit enter. So now anytime you hit x, 4 is automatically in there. If you have the update now, to get this fraction tool, you're hitting alpha y equals. So hopefully you know that by now. Here's the alpha y equals, and you'll see the n over d, which will pull up numerator denominator. Then all you're going to do is type in 2x squared minus 1, arrow down, 2x minus 6. If you've got that old calculator that doesn't have the update, we're sorry for you, but we can still help you out here. You just have to be extremely careful. When you type yours in, you're going to have to do parenthesis, the numerator, close it, divided by, parenthesis, the denominator. And go ahead and type that in, hit enter, and you've got your answer. All right, boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit and it begins to cool. Temperature readings are taken at each hour and are given in the table below. In this scenario, temperature T is a function of the number of hours H. So all I need you to do, you don't need to copy that sentence down, but let's go ahead and copy this table down in your notebook. Pause it when you're ready, come on back. Okay, I need to evaluate T of 2. Now, they told me T is a function of H. So H is my hours, and they have it clearly labeled, and T of H is my function. So if our function is T of H, and they want me to evaluate T of 2, what they're really saying is what is the temperature at 2 hours. Notice the 2 took the place of H. So what is the temperature, capital T, at 2 hours? So I have to go to 2 hours, and my input is 2. My output, so T of 2, is 104 degrees Fahrenheit. Okay, I input 2 for hours, and I got an output of 104 degrees. Let's do T of 6. So this is saying, what is the temperature at 6 hours? How do I know the 6 means hours? Well, it was T of H, and H stands for hours. So if I go to 6 hours, I input 6, and my output should be 68 degrees Fahrenheit. Now B changes slightly. It says, for what value of H, so let's get that question in our notebook, for what value of H is T of H equal to 76? So your question is 76 the input or is 76 the output? Well, remember, the input is in parentheses, the output is what it's equal to. So this time they're telling you the output is 76. So I have to look at my output, which is like my Y value. So just like normal, what comes first in the table is X, the second is Y. So I'm going to go to that table and I'm going to look for an output of 76, and as I scroll through, it's right here. And the corresponding input would be 4. So I would say H equals 4. Part C, between which two consecutive hours will T of H equal 100? Okay, so again, are they giving you the input or the output? If I tell you T of H equals 100, I'm giving you the equals, this is the output. Okay, so I want to know, when is the output 100? Now if you look closely, none of them say exactly 100, and that should make sense because it says between what 2 hours will I get 100 degrees Fahrenheit. So I would scan this again, and I would say 100 degrees is going to fall someplace between 2 to 3 hours. Exercise 3, we need to evaluate these graphically, okay, and it's just as easy. If I want to find f of -1, all you have to say is what goes inside is the input, and input is my x. So I'm going to go to -1 on the x, find the function, and it's right at 0. So f of -1 has a height or an output of 0. F of 1. Okay, so again, the input is 1, which means the x is 1, so I go to x equals 1, which is here, but now I got to find the function, and the function's output is up here. 1, 2, 3, 4. So f of 1 is equal to 4. Last one, I got to find f of 5. Okay, so 5 is being put in, so count over to 5. 1, 2, 3, 4, 5. Now find the graph, which is down here, so the output is -4. B, evaluate f of 0. What special feature on the graph does f of 0 correspond to? Okay, so let's find f of 0. So I'm putting in 0, which is right at the origin there. Find the graph, so I arrow up, here's the graph, and f of 0 equals 3. And what does that correspond to? Well, it's right on the y-axis, so remember that's called the y-intercept. C, for what values of x does the function f of x equal 0? Okay, so again, is 0 the input or the output? Well, remember, the input goes in, so you're finding the input, and 0 is the output. Okay, so basically, when do the y values equal 0? Now, one quick way to find that is to draw a line at 0. So I'm going to say y equals 0 is right here. And let's label it. Y equals 0. I would say there are 3 times y equals 0. When x equals -1, when x equals 3, and when x equals 7. There are 3 times the graph, this function, equals 0. What special feature on the graph does this set correspond to? Well, remember, those are called zeros. Now, they also have another name. We could also call them x-intercepts. And part D, between what 2 consecutive integers does the largest solution to f of x equal 3 lie? Okay, so again, you have to say to yourself, is 3 the input or the output? Okay, well, it's not in the parentheses. This is the output. So if the output is 3, I'm basically just going to draw that magic line at y equals 3. So the output is 3. And it says between the largest solution. So I would say this is the largest solution. And that falls between, we'll have to count it out, 1, 2, 3, 4, 5, 6, 7, and 8. Between x equals 7 and x equals 8. Okay, so the question is, are you finding the input or the output? Exercise 4. For a function y equals g of x, it is known that g of -2 equals 7. Which of the following points must lie on the graph of g of x? Well, again, it's very simple. Just ask yourself, who is the input and who is the output? Who are you putting in and what do you get out? Well, remember, what you put in is in the parentheses, so the input is -2. And what you get out is what it's equal to. It's equal to 7. And input is your x, output is your y. So I need an x of -2 and a y of 7. Hopefully you would agree with choice 2. Alright, lastly, physics students drop a ball from the top of a 50-foot high building, and the model is shown as a function of time here. So using tables on your calculator, determine to the nearest tenth of a second when the ball hits the ground. So the first thing we want to do is hit that y equals button. Remember, h of t is just a function notation for y equals. Our input is the time values, because that's what they're putting in, and we get out the height of the ball. So go ahead and grab that calculator, type that into y equals. So I've got a snapshot of my calculator and my input and output values. So again, t is the input, which stands for time, and it's in seconds. And y, or h of t, is the output, which represents the height. Now, let's think about this. If the ball hits the ground, okay, so physics students drop a ball from a 50-foot high building. So I'm 50 feet high and I drop a ball. Now the ball's going to stop when it hits the ground. And what is that height? My height is equal to 0 if I hit the ground. So I'm looking to see when I have a height of 0. So I'm looking in this section here. So you can notice I'm at 50 feet to start, and then I hit 34, and then all of a sudden I hit -14. So can you tell me between what 2 numbers I hit the ground at, or what 2 seconds? Well, if I went from 34 to -14, I would say the time has to fall between 1 and 2 seconds. Okay, now I'm not going to worry about the nearest tenth for the moment. I'm just going to say it happens between 1 and 2, and we'll talk about changing the table later on. Well, that does it for tonight. Have a great night, and we'll see you in class tomorrow.